Hello, college algebra students. Mr. Record here from Avon High School, and we are with my awesome sixth period ACE College Algebra 2 class today, and we are going to actually be introducing them to the idea of the logarithm. Now, it's possible that a lot of people that might be watching this video, just like a lot of my students, have probably seen a logarithm or used a logarithm. Maybe if you've had a chance to take chemistry very early on in your high school career, you've had your teacher show you this thing on the board that looked like an log or an ln, and you're like, yeah, sure, I can find that thing on my calculator. I can push buttons and compute these, but maybe you don't really quite understand what the logarithm is. And that's what the whole point of both this lesson and the video is. So hopefully, before all is said and done today, our objectives will be met. And the first objective is to define a logarithm, and to do so in a way to be the inverse of an exponential, and then to simplify simple logarithms using some basic properties. And then future lessons will expand upon those properties. So, first part, understanding the value of a logarithm. Well, you're going to see quite often an expression that looks like this. It's going to say log, and then there's going to be a subscript. This b is a subscript, and then there's a value a. And we will read that as the log base b of a. All right, it's possible to say the log of a base b, but it's more common to say the log base b of a. Now, it's very important that we understand a couple of things, you guys. A has to be a positive number. Things are not going to work very well if you try to take the logarithm of a negative number. We'll see why. And your base will always be a positive number because it makes no sense. Logarithms are not defined for bases that aren't positive. And we start by studying this table of logarithm equations below. So in example 1, it says in each box, write the exponential equation that is related to the given logarithmic equation. And as you can see, there are about 1,000 of these boxes. Am I right? Oh, okay, 15. Close enough, right? I don't know if we're going to have to talk through all 15. I'm going to have my class fill out all 15. But we're going to at least talk through a few of them. All right? So let's look at the very first row entry, 1a. It says that the log base 3 of 27 equals 3. Now that might sound like gibberish. That might be like, okay, yeah, sure, Mr. Record, I'll take your word for it. But I want you to all know that that's a true statement. All right, it's legitimate. Right? The log base 3 of 27 is 3. But really, what does it mean? Well, it means that if you take this base, b, and you guys, we call it a base for a reason, because we're going to write it and attach a power to it. That's what you do to bases, right? The power that we attach to this 3 is going to be the number that's by itself in the logarithm. So 3 raised to the third. And then we will set that equal to the a value, which is the number sort of in the logarithm statement, the log of the 27. And then I'm going to ask my class, is that a true statement? 3 to the third is 27, right? Okay, let's look at example B. Is that kind of the same thing? What would be our base? 2 raised to the 4. Is that equal to 16? 2 times 2 times 2 times 2. Okay. And then with part C, 5 raised to the third. That's 125, isn't it? Now, it doesn't matter if you have fractions or decimals or just all sorts of hideous things like square roots, cube roots. You still can use the same approach to rewrite the logarithm as an exponential. Now, what I'm going to do is I'm going to pick about 3 or 4 more that we'll do together, and then I'm going to pause the video, ask the viewers to fill out the rest of it, and then when they resume the video, they'll see the answers. All right? And you guys in my class will do something very similar. Okay? Except I can't pause you. Right? Okay. So let's look at part E. The log base 36 of 6 equal half. That is a true statement. We would rewrite it as 36 raised to the 1/2, and that's equal to 6. Now, do you all, my students, agree with that? Because 36 to the 1/2 power is like the square root of 36. So that's legitimate. Okay, how about H, this really nasty decimal thing here? 10 is our base raised to the -6, and that's equal to point, and I think I'm counting right, 1, 2, 3, 4, 5 zeros, and then my 1. And that is correct, isn't it? Those of you that are very good with scientific notation might realize that 10 to the -6 is just really the number 10, or it's like 1 times 10 to the -6. So you'll take the number 1. I guess I should start with the number 1, and you would move the decimal to the left 6 spaces, which would produce 5 zeros, right? Let's jump down and do J. The log base 4 of 4 cube root of 4 is 4/3. Okay, now if we follow the rules, our base is this 4. The power is 4/3. And supposedly that's equivalent to 4 times the cube root of 4. Now, to be honest, this particular exercise really doesn't ask that you verify if this exponential equation is true, but I can tell you that it is, because if you think about this 4 times the cube root of 4, isn't this like the same as 4 to the first power times 4 to the 1/3 power? Is that a way to think about this? Just multiplying them together, but rewriting the cube root of 4 as 4 to the 3rd. All right, and what happens whenever you multiply like bases? You do what to the exponents? You, of course, add the exponents. You guys know that, right? And you get 4 to the 4/3. So it's legitimate. All right, so what I am going to do is pause the video. I'm going to ask that you as the viewers work through, if not all the rest of the problems, work through a few of them. And then when you come back, you'll see that I will have the answers filled out. You can check them, and then we'll move on to the next part. All right, and we're back. Boy, that was fast. It seemed like it was instantaneous almost, doesn't it? All right, you might be able to check the ones that I left for you are now answered in green. And as I said before, every one of these equations is an equivalent expression. Some of them are so silly that it probably doesn't take a lot to convince you that, hey, look at K. Yep, I'm pretty sure that 3 to the 1/5 is equal to 3 to the 1/5. I'm pretty sure that in N, 5 to the 1st is equivalent to 5. You know, some of them are so obvious, but there are a few that maybe aren't so obvious, like G. But, yep, I'll say that if you took the square root of 9, got 3, and then raised that to the 5th, you would find yourself at 243. Now, one thing I want to show everybody is that a calculator is a great way to compute some of these. For example, if we go back to this A, the log base 3 of 27, it's very likely that depending on your calculator model, you have a button that will allow you to input a log of any base. You would have to have one of the more fancier calculators. Now, in this case, I have a TI Inspire, and I have a very interesting button that I have to push, and I have to access some special things right here. If I go to this option right here, see, this one allows me to input any base that I want, and then I can put the value in. So this would be our problem A, and this should give us an answer of 3, and of course it does. Okay. Now, if you're using a little older calculator, like an older scientific calculator, it's very likely that those calculators may only have this button, LOG, and that's a very special logarithm in that it will only compute a base of, do you guys know in my class what base by default? It's base 10. Base 10 is what the, the LOG button would do. But my students are using the TI Inspire, so it really doesn't matter. They can choose about any base that they want. But it doesn't matter either for any of you watching, because there's a special little trick that you can do to kind of tell your calculator to compute in other bases. Now, it says here at the bottom, based on studying these examples, make a conjecture as to how one would define or find the value of the log base b of a. So if we look at this, what is the log base b of a? Every time, if you guys look at the right side of all of these equations, all of those circled black numbers end up being where in the next step? You see it? They become the exponent. And if anybody was to ever ask me, hey, what is a logarithm? I don't understand. First thing I will tell them, a logarithm is an exponent. That's all it is. It's the exponent that you would raise this little number to. The little base gets raised to that power. So if I have to say, you know, how would one find the log base b of a? I would just simply say that you would raise b to the x power. Now granted, that's if we assume that this is equivalent to x. And then of course we would set that result equal to a. Okay? Now see, that's where this all gets really interesting, you guys. Because if I were to give you a very tricky problem like this, 3 raised to the x equals 5. Does anybody in my classroom know the answer to that? And don't even think about touching your calculator yet. I doubt that too many people know this answer. But that's a thing, right? That's an equation. That's an equation in math that we have to solve. And the only way that we can solve that is to use logarithms. That's why we need logarithms. Because remember how I said a logarithm is an exponent? A logarithm is going to help us find this unknown exponent. Okay? Now, think back to last unit. The people in my class, you were solving things like this. Now, see, this is different. You don't need a logarithm to find this, do you? Because you can write 2 and 32 with the same base. How would you rewrite 32, you guys? You'd love it to have a base of 2, so what would it be? 2 to the... And if you have to count them, that's fine. All right, just count on your fingers, starting with my thumb. 2 to the first, there's 4. 2 to the second. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. Right? So this is 2 to the fifth. I had to draw the hand. How do the people watching the video know what I'm doing, right? So x is going to equal 5. See, this is easy. The stuff in green is easy, but this stuff over here in black is not so easy to do by hand. Well, in fact, it's impossible to do by hand. So we're going to introduce technology and a calculator. And that's actually going to be in a later lesson, you guys. All right, couple of conjectures here. Make 3 conjectures about the value of a logarithm based on the numerical relationship between the value of the base b and the value of the argument. And that's what we call the thing after the word log is called the argument of the logarithm a. So if b is equal to a, so for example, if we find the log base 5 of 5, what do you guys think? What power do you raise 5 to get 5? 1. Is that always going to be true? Is your answer always 1 if these two guys are the same? Yeah. So your argument is, let's see, make 3 conjectures. If b is equal to a, then how should we say this? We'll say the result of log base b of a is 1. Okay, I think that's the easiest of the three conjectures. Now this is going to be a little trickier. What if b is less than a? So what if I've got the log base 2 of 5? Now what power do I raise 2 to get 5? Well, that's a tough question because nobody knows the answer to that. But can you tell me what it's a little bit bigger than? It's bigger than 1. Okay. Is it between 1 and 2? Is it between 2 and 3? What do you think this answer is going to be between? And I think you had it. I think you said it's close to 2, right? So that's exactly right. This is going to be something close to 2, somewhere between 2 and 3. Now, you guys, I'm not so concerned with what the actual answer is. I just want you all to know that the result is going to be larger than 1. Okay? It's a number bigger than 1. Okay? Now, based on that, I want you to be able to tell me, what if you saw this? What if the base, in this case I'll use 5 again, was larger than the argument? What power would we raise 5 to get 2? Is it going to be bigger than 1 or smaller than 1? It's going to be smaller. And that's kind of our first realization here. Okay? All right. Moving on to the next page here. Talked about this a moment ago, and I said a logarithm whose base is 10 is called a common logarithm. Common logarithms are so, dare I say, common that sometimes they don't need the b value written with them. So if you ever see a log without a base, like log 100, what we will do is just assume, we will assume that that's the same as the log base 10. It's not wrong if you guys wrote the log base 10. It really isn't. And in fact, it doesn't look like shameful. But I just want you to be prepared. If you don't see a base, you assume it to be a 10. All right? So, for example 2, it says, use a calculator to find the values of each of the following common logarithms. It's up to you guys. If you want to drag out an older calculator just to kind of see where these buttons are, you're welcome to do that. But please understand that we now use the TI Inspire pretty religiously in this class. Now, with that being said, on your quiz that you guys would have over this, and on the unit exam that has the calculator part, you're allowed to use any calculator except the TI Inspire CAS. All right? So if you have your TI-84, you can use that. If you have an old scientific, you can use that. If you don't have either of those, I can have a few older calculators in here, but we want to make sure that you guys practice with those because I want you to know where the log buttons are. Okay? It's very likely you're going to use the calculator that you guys used probably in your Algebra 1 class, right? Or your Chem class if you've taken Chem or whatever. So it says use the calculator to find each of these values. So what is the log of 5? Well, I go to my calculator and I would type, my log button is actually Control 10 to the x. You can see how the log is in blue, so I have to access that up here. Now, what if I try to be a rebel here and I skip that box and don't fill it in? Okay? If I don't fill that box in, the calculator will understand it to be a log base 10. Now, if you're using a CAS calculator, you're going to have this problem. The calculator is just going to spit right out what you put in, right? Because it's like, hey, I can't do this problem unless I convert it to a decimal, and that means I have to approximate it. So what you're going to have to do is either hit Control Enter, and that will give you the decimal version, or if you want to beat all that, hit Control 10 to the x. Be a rebel, right? Don't put the 10 in. It's okay. But just put a decimal place after your argument, and then it'll go right to the decimal answer. Okay? And we have our answers set to, I guess, give us like maybe 5 decimal places or whatever. But I want you to realize that if I highlight that and hit enter, it's a long decimal. It is a non-terminating, non-repeating decimal. It's probably it's definitely an irrational number. But if you guys round to at least 3 places, I want to try to get you guys rounding to the AP Calc exam rules. I'll let you say 0.698 or 0.699. All right. I am going to pause the video, and I would like those of you watching to use your calculator to find B and C, and then you can check them with me when you're done. And once again, we're back. Hopefully you can see the answers to my B and C. Hopefully they agree with yours. Very interesting that this log of 100 was an exact value of 2. Probably didn't need a calculator for it, because you could take 10 to what power is equal to 100. Right? That's why I put an equal sign there. But over here for the log of 115, I had to round this at 2.061. I think it's like 2.0607. So I used an approximate symbol. I'm not going to require that my students put this approximately symbol there, but it is nice to acknowledge the fact that we did round, so an approximately symbol would be a better tool to use there. All right, let's go ahead and look at this next part, which is sort of an introduction to the magical formula that basically allows all calculators to be sort of equivalent in this world. And it says, based on our understanding of the value of a logarithm, what conclusion can you make about the values? Well, let's go ahead and look at these logarithm expressions and fill in the columns. Second column says, find the value of the given logarithm. If the value is not an integer, between what 2 integer values do you think the value of the logarithm expression lies? All right, so we look at the first one, log base 3 of 81. All right, now without a calculator, is there a nice power that you can raise 3 to get 81? Right. So in other words, we're thinking 3 to what power is 81? What do you think, guys? Is that a nice answer? What is the answer? It's 4. It's 4, isn't it? Now, some students are like, well, how do you get that? Okay, it's number sense, but you could also think of it as changing the base. 81 can be written as 3 to the 4th, right? Because we have a nice base on each side that's the same, we can say that x is equal to 4. So we don't have to answer the second part of this question. Okay? Now, I'm going to wait and do the third column until we're finished. Let's look at this next guy. 2 to what power is 1/8? So this is what we're thinking. 2 to what power is 1/8? Now, it's possible that some of you out there, some of you watching this, might be able to immediately jump all over what that exponent is. That's great. But if you can't, try to rewrite the 1/8 as a base of 2, because that's answering the same question. So 1/8 is the same as what? 2 to the 3rd power, right? That's 8. But, oh, this 8's in the denominator, so I need to make that 3rd power a negative. Now that my sorry, guys, this should be an x. Your teacher's dumb. That should be an x. Now that my bases match, they're both 2, I can set the exponents equal and get -3. All right. Now, I think that that is about to stop. Look at the third one. 2 to what power is 9? Anybody in my class know this answer? If you can give this to me to 3 decimal places without using a calculator in the next 10 seconds, I will give you my car. Anybody want to take a guess at that? And you can't use one either. We don't know this, right? All right. Now, I'm not going to give you my car, but can you guys tell me between what 2 integers it lies? Bigger than what? Smaller than what? between 3 and 4. Very good. Because 2 to the third is 8, and 2 to the fourth is what? 16. And 9 lies between 8 and 16. So that's kind of what they're looking for if you don't have an integer value. All right? All right. I am going to, guess what? Pause the video. I would like everybody to go ahead and fill out these 3 cells, and then you can check your answers with me when you're finished. And we're back. Hopefully you guys can check these 3 results, and you match what I've got. Now, if you'll notice this very bottom one, this bottom one sort of tricked me a little bit. I had to think about this a little bit. So you notice the little extra step that I put down here. I knew that 3 to the fourth was 81 because we've already talked about that earlier in this video. And I knew that 105 is bigger than 81. So I wanted to make sure that 3 to the fifth was going to be larger than 105. And it is. Now, if you wonder, how do I find 3 to the fifth power? Am I just naturally smart? Well, okay, yeah, a little bit of that maybe. But 3 times 3 times 3 times 3, which we know is 81, 81 times another 3 is going to be 243. I'm not naturally smart, right? I just use clues within the problem. Now, this next piece is very important, and really the only way to get anything out of this is to probably have a calculator in front of you, or in my students, you can watch my calculator here. But I want you to find the values of these of this quotient. You're going to basically take the logarithm of the a, divide by the logarithm of the b. Now notice those 2 logarithms don't have bases attached, so what are their bases defaulted to be? 10. So you're going to take the log base 10 of like 81 and divide by the log base 10 of 3. All right, well, let's do that. I'm going to switch over to the calculator. In fact, I've got a lot of stuff on my screen here, so I'm going to clear that. Start from scratch. So remember, to get my log, I hit Control 10 to the x. I'm going to leave that. Actually, I'm sorry. I'm going to do something completely different. I'm going to get a fraction template, so I can hit Control Divide. For those of you that might be using a T84, I think you can hit something like your second key, function key, and then the F1, and you can access your fraction template. Now I'm going to hit Control 10 to the x to get log. And for this problem, the a we said was 81. And then for the bottom, I'm going to take the log of 3. Now, I want to go ahead and make sure that one of these is a decimal. Not that it probably matters in this case, but I'm going to go ahead and continually make one of them a decimal so that I can spit out a decimal answer if that's what happens. And if I hit enter, what do I get? Does that answer look familiar to you? That was the result that we got when we just simply solved this logarithm. See, that's how a person who doesn't have a log base 3 button on their calculator can compute a log base 3 on an old-fashioned calculator. All right? Old-fashioned. When I say old-fashioned, I mean like 2005. That's scary that 2005 is old-fashioned. Okay? So I have 4. All right, we're going to do the same thing for this next problem. I'm going to bring up my, you know what I'm going to do? I'm going to do this. I'm going to really be clever. I'm going to just copy and paste this whole expression. Then I can just edit. So for the second problem, this is supposed to be 1/8. And this stays, or this becomes 2, right? Well, if I hit enter, I end up with -3, and that's exactly what we got earlier. All right. Now, I will spare everyone the arduous task of pausing the video and computing these other 4 boxes, but I will guarantee that you're going to get an answer between 3 and 4, 3 and 4, 2 and 3, 4 and 5. In fact, let's just jump right down to this last one. All right? I'll jump right down to the log base 3 of 105. So I'm going to go up here, grab this, and then I'll rip out the 1/8 and put a 105, and then I'll put a 3 here, and my answer is a decimal output, 4.236, and I recall saying that the answer was going to be between 4 and 5. Okay? Nobody would have guessed that, right? Nobody could have won my car, right, in my class. All right. So what can you conclude about the values of the log base b of a and the log of a divided by the log of b? What do you guys think these are? They are equal, right? They are equal, and that's awesome because it provides the means by which anyone with any type of scientific calculator, all you need is an log button, and you can compute the log of any base. All right. Now, I'm going to stop this video here, and I invite everyone to tune into the next video, which will be entitled Developing the Natural Base of E, and I'm going to talk about this brand new number called E, and we'll finish up these notes and move into the last example where students will actually solve logarithm equations, right? Which is really the main focus of this particular lesson. Really what I want everyone in my class to be able to do is what you guys see here in example 3, because it's a very important part of your math development. All right? But for now, I will see you next time. Hopefully this helps.